Good afternoon, students. I, Professor Arvind Medyabiha, welcome you to the subject Kinematics of Machines. In the previous class, we have come across the syllabus, the objective of the subject, what are the contents, and what are the different modules it has, and the reference books and about the textbooks. Today, we are going to start with the syllabus, starting from module number 1. The module number 1 is the title is the mechanisms, under which you are going to study the basic definitions, the basics elements which are required to form the mechanisms, and how the machines are formed with the help of the mechanisms. It is nothing but you are going to study about the mechanisms overall and its motions. So before we start with these definitions of the mechanisms, first let us know what is a machine. So in simple words we can say machine is a device by means of which available energy can be converted into desired form of useful work. So the whatever the energy is available, that we are converting into useful work. Such a device we can call it as a machine. So this is how we can understand the machine. And if we come to this chapter, basic terms concerning to theory of machines such as links, pair mechanisms, kinematic chain, degree of freedom, etc. are discussed. In the end of the chapter, we can solve two problems on degrees of freedom, and we'll come across the inversions of motions, that is mechanisms. So I said theory of machines. So what is this theory of machines? It is the branch of engineering which deals with the relative motion and forces between various machine elements. So this subject is this theory of machines. Theory of machine is divided into two parts. One is kinematics of machines and dynamics of machines. And you are going to study the kinematics of machines in this semester. So this is how the subject name is kinematics of machines. It is derived from theory of machines. That is, theory of machine is a subject which is divided into two parts. One is kinematics of machines and one is dynamics of machines. And you are going to study the kinematics of machines. So what is this kinematics of machines? It is that branch of theory of machines which deals with the study of relative motion of various machine elements without the consideration of forces. It is also called as a pure mechanism. So kinematics of machines, it does not deal with the forces involved in the motion. So it is only about the relative motion between the parts, that is called as the kinematics. And when we study about the forces which involved in this motion, then it is called as the dynamics. So this is about the kinematics of machines. And mechanism, it is that branch of scientific analysis which deals with the motion, time and force. It can be also it can be also taken in the way when one of the links of kinematic chain is fixed. That is also called as a mechanism. So when we are going to fix one of the link in the kinematic chain, that is also called as a mechanism. What is this kinematic chain and all, we'll study it later. So basically what you have to understand, mechanism, in the mechanism we deal with the motion, time and force. Next we have plane motion. A body has a plane motion. So when we can say a body has a plane motion, if all its points move in the planes which are parallel to some reference plane. So body has to move in a plane parallel to the some reference plane. Like if you take when we take a duster rubbing over the board, we can say the motion of the duster is plane motion because it has a parallel to the plane, the board. Okay, so this is how the plane motion can be understood. Now this plane motion can be of three types. One is translation, second one is rotation, and third one is a combination of translation and rotation. Next definition we have link or element. So how to define this link or element? It is the name given to any body which has motion relative to another. That we can call it as a link. Or in another way, the link can also be defined as link or element is that part of machine which has motion relative to some other parts. So it has to have some relative motion with some other part. Okay, then only we can say it as a link or element. This must be capable of transmitting the required forces with negligible deformation. So when we talk about link or element, it has to transmit some kind of force and with very negligible deformation within it. Therefore, it should have two characteristics. What link or element should have two characteristics. One, it should have relative motion, and second one, it must be resistant body. Why it should be resistant body? Because it should have negligible deformation when it transfers the force. That is why it should be a resistant body. Next, these kinematic links are classified as rigid link, flexible link, and fluid link. So rigid link. So it does not undergo any deformation while transmitting motion. So a rigid link is a one which do not experience any kind of deformation when it transmits the motion. And example, you can take it as a crankshaft or connecting rods where there is a very negligible, very minimum deformation is occurring. Next we have flexible link. It is partly deformed while transmitting motion. Such links we can call it as a flexible link. And examples are clearly we can see it is a belt or springs, etc. So we have seen the belt drives and all where motion is transmitted from one shaft to another shaft and the belt will go through some deformation. That is which is a very flexible element. Similarly, springs. Even springs are used for transmitting motion, and that motion is possible only with the deformation of the springs. So spring is also a flexible element. So that also comes under the flexible link. Next we have fluid link. It is one in which the motion is transmitted to the fluid pressure or compression. So any hydraulic pressing machines you can take. It is an example of fluid link where fluid pressure is used for transmitting the motion. And examples are hydraulic press, hydraulic brakes, etc. We can consider for this fluid link. Next, we will see the kinematic pair. So, what is this kinematic pair? It is a combination of two kinematic links. Okay, in the previous we studied about the links. Now, kinematic pair is a combination of this link, combination of two kinematic links, such that their relative motion is completely constrained. Constrained means it is fixed in some direction. or its motion is restricted, such a motion is we call it as a constrained motion. So kinematic pair is a combination of two kinematic links such that their relative motion is completely constrained. And next we have kinematic pairs, types of kinematic pairs. So again it has a broad classification. The first one is based on the nature of contact between the elements, how the two kinematic links are in contact, or how the two bodies are in contact. Based on that, kinematic pairs are classified as lower pair, higher pair, lower pair and higher pair based on the contact. And first we see what is this lower pair. If the joint by which two members are connected has a surface contact, the pair is known as the lower pair. Okay, so when two bodies are in surface contact, we can say it as a lower pair. When the two bodies are in contact by surface, then we call it as a lower pair. Okay, here we can see this is a cube and it has a one slot. In that we are inserting this beam. So this surface and the inside the cube surface are in completely contact. So this we call it as a lower pair because there is a surface to surface contact. And similarly here you can see the shaft, the rotating under the bush. Okay, this is the bush. The shaft and the bush, okay, are in surface contact. So this comes under the lower pair. So when there is a surface to surface contact between the two bodies, then we call it as a lower pair. Then what is this higher pair? If contact between the pairing elements takes place at a point or along a line, such a contacts are called as a higher pair, such as a ball bearing or between two teeth in contact, there will be a line contact. So such a contact is known as a higher pair. So what you have to remember here, in higher pair, there is a line or point contact between the elements. The contact surfaces of the two elements are not like or similar. That means it is not a surface contact. Okay? It is going to be point contact or a line contact. And other examples we can take cam and follower also comes under this higher pair. Ball and roller bearings. Okay, here you can see this is also one example of a higher pair where the two elements will be in contact by point or by line contact. So that is higher pair. Next, based on the relative motion between pairing elements. So how the two elements which are paired are having the relative motion. Based on the types of relative motion, it is classified as sliding pair. So two elements are connected such a way that one is constrained to have a sliding motion relative to the other. So there will be 1 degree of freedom between them. It is known as a sliding pair. Okay. Again here you can see in this example, this slab can slide under this slot under the cube. Okay. Only this motion is possible here. Okay. So this is called as a sliding pair. Okay. So this is called as a sliding pair. It can slide only in forward or backward direction. It can only slide, it cannot rotate. Okay, so this is called as a sliding pair. So that is having 1 degree of freedom. Next, turning pair or revolute pair. When connections of the two elements are such that only a constrained motion of rotation of one element with respect to the other is possible. The pair consists of turning pair, okay, is an example, and again it will be having 1 degree of freedom. Okay, again if we take this example, okay, if we take this example, here the shaft will be rotating under the bush and its sliding motion is restricted and it can only rotate, then it is called as a turning pair. Okay, that is nothing but shaft rotates in a bearing or rotation of crank in a slider crank mechanism is another example of a turning pair. Okay, so if the shaft is restricted for sliding and if it is allowed only for rotation, then it becomes the turning pair. I hope you are following. After watching the video, still if you have any queries, okay, directly you can contact us, okay, for the more details. Next, okay, the same the what I explained, the same figures are, this is example of sliding pair, this is example of turning pair, and next we have cylindrical pair. The relative motion between the pairing elements is the combination of turning and sliding, then it is called as a cylindrical pair and it will be having 2 degrees of freedom. So here motion of rolling wheel on a flat surface in a belt drive pulley can be considered as rolling on a belt. The belt and pulley surfaces constitute a rolling pair. Okay, that is one of the examples of the cylindrical pair. Joystick is another example of the cylindrical pair, where we can find the ball will be sliding in the slot, okay, which will be having both sliding and rolling kind of motion. So that comes under the cylindrical pair. Pardon students, I will explain once again this cylindrical pair. Cylindrical pair is the one where the relative motion between the pairing elements is the combination of turning and sliding. Okay, then it is called as the cylindrical pair, and because of turning and sliding motion, it will be having 2 degree of freedom. Okay, and rolling pair is different. The rolling pair is the one when pairing elements have rolling contact, that pair formed is called as a rolling pair, and that rolling pair will be having only 1 degree of freedom, where we can take example of belt and pulley. The belt and pulley is a good example of this rolling pair, where we can see that motion of rolling wheel on the flat surface. In a belt driven pulley can be considered as a rolling on a belt. So belt and pulley surfaces constitute a rolling pair. So that is the example of the rolling pair. And next we have a spherical pair. A spherical pair will have a surface contact and 3 degrees of freedom. Okay. For that example we have a ball and socket joint. So here you can see the example of ball and socket joint here. That is the example of the joystick what we are discussing. So here the joystick will be having 3 degrees of freedom. where a spherical pair is formed. So here you can see this is the ball element and this is the socket. So we call it as a ball and socket joint. Okay. So spherical pair is having 3 degrees of freedom and the joystick is the one of the example for this. Next we have helical pair or screw pair. When the nature of contact between the elements of a pair is such that one element can turn about the other by screw threads, it is known as a screw pair. Example, nut and bolt. Again, it will be having 1 degree of freedom. Okay. So here you can see that this is the bolt and this is the nut. Okay, where it will be having a relative motion, okay, between them in such a way that one element can turn about the other, okay, and it will be having the relative motion between them. Such a pair is known as a screw pair. So you can imagine, or you can consider this bolt and nut pair where you can see that the one element will be having a motion with respect to other, okay. In this type of pair, contacting surfaces are having threads, and because of this only it is known as a helical pair or screw pair, and one element turns about the other by means of threads only, okay. So it is called as a screw pair or helical pair. A bolt and nut arrangement is a good example for this, where both the elements will be having threads on it, and because of threads only the motion is possible. Such a motion is called as a helical pair or screw pair. Next one is based on the motion of mechanical constraint. So in this, the first one we have closed pair. In this, elements of pairs held together mechanically due to their geometry constitute a closed pair, also called as a form closed or self-closed pair. Okay, and this is the figure which gives the example of this closed pair. Okay, where you can see no external devices or no external forces are used for holding these two pairs together. Okay, you can understand there is no external force or device are used to constrain or hold these two bodies. Okay, because of that it is called as a closed pair. Okay, you can see the definition once again. Elements of pairs held together mechanically due to their geometry constitute. So their geometry is such a way that because of that geometry only those are held together. So it is called as a closed pair. Next we have unclosed or force closed pairs. Here elements of pairs held together by the action of external forces constitute unclosed or force closed pair, and for that example is a cam and follower. In this, to hold the element together, external forces are used or external arrangements are used to hold them together. Such a pair is called as a closed pair or unclosed or force closed pairs. So in this cam and follower example, you can see that cam is fixed with the help of this pinpoint. It holds the cam, and the follower roller is fixed to the follower, and again follower is holded with the external arrangements. So this is called as a force closed pair. Next we have, so that is all about what we were discussing about types of kinematic pairs. Now we shall discuss about the constrained motion, okay, in the next class. So in today's class we studied about what is theory of machines, what is machines, what is theory of machines, and what is kinematics of machine, what is dynamics of machines, basic definitions like mechanisms, plane motions, okay, and what is link or element, how kinematic links are classified, and what is kinematic pair, and how these kinematic pairs are classified with the examples and sketches. So I request all of you to practice these sketches and understand the subject, understand the concept, understand these sketches, and try to write on your own about explanation about these sketches. Okay, and the sketches are important in the examinations as well as for understanding purposes, and clearly understand this kinematic pairs and types of kinematic pairs. Okay, in the next class we shall start with the constrained motion. Okay, if you have any queries, you are free to ask us directly on a phone call, okay, or you can WhatsApp also. So practice the sketches. Okay, we'll meet in the next class. Thank you.